So here we are provided with 3 points and we need to show that these 3 points are the vertices of a triangle. But we also need to find out what type of triangle is going to form. So let us begin. So let's name each of the point. So we have a triangle, a generic triangle. We'll call the vertices as A, B, and C. So let point A has the coordinate A, comma, A. Let's say B has the coordinate negative A, comma, negative A. And then C has the coordinate negative square root of 3 times A, and the y coordinate being negative square root of 3 times A. So this is the coordinate of point C. Now what we'll do, we'll try to find out the length of each of the sides of the triangle. For this, we'll have to use the distance formula. So let's first specify the distance formula. So here we have 2 points, point A and point B, whose coordinates are given. Then the length of the distance between point A and point B, which is a straight line, is given by square root of, underneath the square root, first we take the square of the difference of the x coordinate and add it to the square of the difference of the y coordinate. Fine. Okay, so now that we have the distance formula, we'll use it to find out the value of AB, beginning with AB. So AB is going to be equals to, we have square root of, so we need underneath the square root first, square of the difference of the x coordinate. So here we'll start with A and subtract from it negative A. So A minus negative A, so that's going to be positive 2A. This will be added to when we'll have the difference of the y coordinate squared. So we have A minus of negative A, so that's going to be 2A squared. So this is going to give us, we have 2A whole squared, that's going to be 4A squared, plus 2A whole squared, so that's going to be 4A squared, and that's going to give us a length square root of 8A squared, which is nothing but 2 times square root of 2 times A. So that's the length of AB. Let's try to find out the length of BC. So BC is going to be equals to, so we have square root of, since we are considering BC, so we'll do first the difference of the x coordinate. So that's negative square root of 3 times A minus of minus A. So that's going to become positive A. So we have negative square root of 3A plus A whole square. This will be added to difference of the y coordinate. So that's square root of 3A minus of negative A. So that's going to be positive A squared. So let's try to simplify this. So we're going to get, we have, let's expand it by using A plus B whole square. So we get negative square root of 3 whole square. So that's going to be simply 3A squared. Then plus A squared. Then we have negative 2 times square root of 3A squared. Now coming to the next term, we are going to expand it to get 3A squared plus A squared plus 2 times square root of 3 times A squared. So here 2 times square root of 3A squared will get cancelled out. 3A squared, A squared, that's 4A squared. 4A squared plus 3A squared, that's 7A squared. Plus A squared will be 8A squared. And this is also going to give us 2 times square root of 2 times A. So here we have obtained the value of BC. It turns out AB is equals to BC. Then finally, we'll try to find out the value of length AC. So AC will then be equals to, we'll take the square root. Underneath the square root, first we'll take the difference of the x coordinate. So let's start at A. From it, we're going to subtract the x coordinate of point C. That's going to be positive square root of 3A whole squared. This will be added to the difference of the y coordinate. So we start with this particular A, and from it subtract this A. So we have minus square root of 3 times A, and then square it. So when we calculate it, we're going to get the value 2 times square root of 2 times A. Hence AB, we're getting AB equals to BC equals to CA. All the 3 sides of the triangle are equal. So that means ABC is an equilateral triangle. Since ABC is an equilateral triangle, coming to option, so option A is going to be the correct answer.